This video is an introduction to RStudio. So by the end of today, you should be able to understand how to put data into RStudio, how to work with some of the data sets that are already included, and how to create some of the basic stats. So things like means or adding and subtracting. So to get started, we'll open RStudio. So I have it already installed. If you don't have it installed yet, visit my other video on how to install RStudio. So we're gonna open RStudio and it's gonna take us to the introductory window. So this is how RStudio looks and what you will be working with most of the time. There are 4 different sections to RStudio. You have the environment in the top right. So this will store all of your data. So any data you store, it will be visible here. You have a plots window at the bottom. So this will show all of your plots, all of your outputs. So stuff that is like helpful to you, or your files, input and output, that will be shown here. On the left, you'll see the actual code. So this will display the code that you write and all of the outputs that the code creates as well. There's a 4th window, so that's the code that you wrote in the past. So basically the way RStudio works is you write some sort of a code and then you run the code and it gives you the output, right? So to actually write the code, I could start typing it here into this window here, which is the console, which shows my code and the output. But to be a bit smarter about that, I'll actually create like a sheet for me where I can save my code, because here at the moment I can only type 1 line of code at any single time. But what I would actually like to do is type a few lines that I can remember what I typed in the past. And that's actually the real powerful thing about R, is that you can type in a lot of lines and you can edit them and run them again if it doesn't work the way you want it to work. So for that, what I'll actually do is create a new file. So I'll go into File in the top left, and I'll create a new file, and I'll create an R script. So this makes a new script for me. And you can see I have a new window here, and now I can type many different lines of code, and I can actually run certain lines, or I could either run the whole thing, or I can pick which lines I want to run, which is gonna be quite useful later on. So to actually start working with this, before I do anything, I'll save my sheet here. So this actually gets saved. I'll click the save button and I'll pick where I want to save it. So I'll save it into my documents for now, and let's just name it test and save it. And now you can see this is actually saved as test.r, which is an R document called test that I just created. So let's start working with some of the basic data. I'll try to explain some of the basic functionality of R. Could be a bit overwhelming at first, but I think it's actually pretty straightforward once you understand the basics. So the basics are that the code runs at the bottom. So anything even if I type it here, it's gonna run in the bottom, right? So I can either create my code at the top, or I could run it directly from the bottom section. The advantage of writing at the top is that I can write different lines of code and it saves all of them, and then I can choose to run some of them or all of them. The advantage of running at the bottom is that I'm not messing up my document at the top. I'm just trying things at the bottom, and it's not actually gonna be saved anywhere if I don't choose to save it into my code at the top. So what R can do is it can actually do a lot of calculations. Something really simple, 1 plus 1, I type it in the bottom. I click enter and it gives me an output, and the output is a matrix, so a set of values. There's one value in the output, and the output is 2. So it's saying 1 plus 1 is a group of values, and there's only 1 value in the output, and that's 2. So that's how you should read the output. You could do anything else, 3 plus 3. For any sort of maths you want to do, you can do it here. It's very straightforward. You could do the same thing from the top. So I could choose to write 1 plus 1 here. And to actually run the whole thing, so if I wanted to run the whole code, let's say I have 2 lines here, I can click run. And what this is gonna do is it's gonna run the current line or selection. So if I select 2 plus 2 and I click run, it's gonna run 2 plus 2 for me, and that's 4. Or I could do 1 plus 1. It's gonna run 1 plus 1. If I choose both, it's first gonna run the first one, 1 plus 1 is 2, and then it's gonna run the second one, so 2 plus 2 is 4. So it runs them in order that they appear in at the top. So this is some really basic functionality, but what you actually want to do is use some functions. So to process bigger data or more complicated data. And to do these functions, to find these functions, what you can use is a help section. So to access the help section, you type in 2 question marks into the bottom console, and then you type in what you want to find. So let's say we want to do a mean, so I type in 2 question marks mean, because I don't know what the mean is. And what this does is it searches all the function here in the help window. So it searches everything that there is in R, and it returns all of the functions and their descriptions. So what I was actually looking for is the arithmetic mean, which is like the mean that you're used to from stats. And I can click the function, and it tells me what the name of the function is. So this is called the mean function, and it's in the base package of R. Once you install more complicated packages, the functions will be located in those packages that you installed, but you don't have to worry about it for now. You have a description of the function, so this is what you should read to understand if this is a function you're looking for. And you have the usage, which is really important. This shows you how you should type in the function to actually make it work. And you have some arguments, so this tells you what you can type into the function, right? So you could type in mean, and this is an example of that function. And usually at the very bottom, you have examples of how to do this. So it gives you like a quick example of how to run a mean on some sort of a data set. So let's talk about data sets. Let's say you want to store some of your values in R, right? So we have 2 plus 2 here, that equals 4. But if I want to save this somewhere, right? At the moment, it's not saved anywhere. It just gives me the value, but it's not anywhere. I cannot really work with that value. If I wanted to store that value, I would have to create a name for that value. So come up with some sort of a name. So let's call it, how should we call it? Like a test value. This can be anything, right? This is just the name I'm giving for that value, for that variable. So I type in test value. Then I do like a little arrow. So I do the symbol for greater and for minus. And this is like an arrow pointing to test value, space. And then I put in the value that I wanted to take on. So I do 4, something like that, right? So what this is actually saying is that I'm creating a new variable that is called test value. And this is assigned to 4. I click enter. And you can actually see that in the top right, where it stores my environment, all of my data, it created a new value called test value, and this is 4. If I want to work with that now, I can type in test value. You can see it remembers all my values now, all my variables, so it knows actually this exists in my environment. But I can type in test value, click enter, and it returns the value of that variable that I created in the past, right? So what you could also do is to test value and assign 3 plus 3 to that, right? So it's gonna overwrite what I had in the past. So it's gonna take test value, and test value will become 3 plus 3, which is 6. So you can see in my values in top right, I have a test value, and that is 6. So this is how you create a data set, right? This is how you create data. You create some sort of a variable that you give a name, and you assign some value to that variable. At the moment, I'm just assigning single numbers, but I can actually assign a set of numbers to a variable. To define a set, so let's say we want to have like 1, 3, and 5, right? I want this to be my set of numbers that I want to assign to some sort of a variable. If I just do it like this, it doesn't know what it is, right? It doesn't understand what I'm trying to do. So I have to tell the system I'm actually creating a set of numbers, and I want to process the set of numbers. And to do this, we use a function called combine. So this is just C. So this is a function that tells it you should take all of these numbers and put them into some sort of a set. So you create C as in combine, bracket, and into the brackets you type the numbers that you want it to be, 1, 3, 5. And this is telling it, take all of these numbers and put them into a set. Click enter, and you can see I have one sort of a matrix that has 1 row, and in the first row we have values 1, 3, and 5. I did not save this anywhere, so this is not assigned to any variable, but I can assign it, right? So we know how to assign variables now. So I can come up with a name. So let's say test variable, and I'm assigning a value, and the value is actually gonna be a set of numbers, and it's 1, 3, and 5. So this is saying create a new variable and assign some sort of a set of values to it. And I can click enter. And this creates my test variable here. And you can see a bit more information than if it's a single value, right? So you can see this is called test variable. And you can see this is numeric, which means it consists of numbers. There's 3 numbers in the set. There's 1 row and 3 columns, and the values are 1, 3, and 5. So I can type in test variable, and it's gonna return my numbers to me. Because I kind of like this function, I can actually save it, right? So I can take it from here, copy, Control C to copy, and paste it here. So this is going to just save it for me, so I know that I have it here, right? Then I can actually start doing some sort of an interesting calculation with these numbers. Let's say we want to do a mean, so we already know that for the mean, it's a mean function. So let's try to remember how to do that again. I'm looking for a function, I'm doing 2 question marks, and I'm looking for a mean. You don't have to do this, but this is just to find the function, right? I'm looking for an arithmetic mean. And this is how to use this, right? So mean, and in the brackets, I put in the data that I want to create the mean out of. So let's try this now. I'm going into the left bottom, into the console, and I'm doing a mean. And in the brackets, it says x. So x here is an R object. So this could be my variable here. So I'll do a mean, and the mean that I want to do, I want to basically do a mean out of my variable. So I want a mean, and the mean is gonna be done out of this test variable here. And I click enter, and the mean in this case is 3. If you're really confused about how to do this, you can always look at their example in bottom right. So they create something similar to what I did. They create a set of numbers, and they create a mean out of those numbers. So let's say I want to save that mean. So I'll do test variable m as in mean, and I'm assigning a value to that, and the value it's gonna have, it's gonna be the mean of test variable. So test variable is the set of numbers I created up here, 1, 3, and 5, and I'm assigning a mean of that to a new variable that's gonna be test variable m. Enter, and you can see I have my test variable in the values section here. I kind of like this, right? So I can also take it and copy paste it here, and this is a new line of my code now. So let's say you want to just practice on some data. You would have to import data into the system so it understands what the data is. But for simplicity and just for practice, what RStudio or R does for you is it includes some default data that you can use. So they took data from different kind of parts of the world, right? Kind of data that's useful to us, and they took the data and included it with RStudio or R. So to access that data, you just type in, let's go into the console. If you type data and close brackets, it's gonna list all of the data sets that you have access to. So here at the top, you can see all of the different data sets that we have access to. For this part, we want to do 2 things. So I want to teach you how to do a t-test, and I want to teach you how to do a correlation. A correlation is going to be easier, so let's start with the easier one first. Let's start with a correlation. And a good dataset that we can practice correlation on is a dataset that has cars in it, so it tells us how different cars work. And this one is called, I think, M. Let me just find it really quickly. MT cars. So this is a motor trend car road test. So they took a lot of cars and they ran tests on those cars, and they give us the data. So you don't have to do anything. This is already included in the data set, right? In your data. This is called MT cars. So if you just want to see that, you just go into the console and you type in MT cars. So this is kind of similar to what we did before. This is a variable, and this variable is already created for us, and this contains a lot of different information. So I can type in MT cars, click enter, and it returns all of this information to me. So we can kind of see that there's a lot of info, right? It has some car names and a lot of different values. Because this is so long, it's really hard for me to understand how this dataset works. It's kind of hard to understand what the different columns are, what they mean, how many different numbers there are in the columns. And what I would actually really like is like a description of this data, right? So there's actually a function for that in R, and it's called structure. So this tells you what the structure of a value or of a variable is. In this case, the variable empty cars is this whole data set here. So it's going to give us a nice structure of the whole data frame. So in R, this is called a data frame. A data frame has rows and different sorts of columns, and this would describe it for us. So structure, to get a structure of something, I type str as in structure. You can see this is a function. If I wanted more information on this function, I could just do one question mark. So if I do two question mark, it searches all the functions. If I do one question mark, it describes what the function following the question mark is. So this is quite different. If I do two question mark and structure, what it's gonna do is it's gonna search all of the functions for the word function. But I know this, sorry, for the word structure, right? So it searches all of the functions that it knows, and it tells it list all the functions that contain the word structure in them. But this is kind of an overkill for what I want at the moment, right? I just want to run the structure function, and I know that it's called str. So just to better understand that one that one function that I know the name of, I just do one question mark and I type in str. And this tells the system, I know what the function is called. It's called str. Could you describe it better for me? And this is one question mark. And this does it for me here. So it compactly displays the internal structure of an R object. And it gives you a few examples always at the end, which is really, really nice, right? So you have examples here. There's a lot of examples for this one. So if you can do all sorts of structures, right? And it gives you results. So I'll just show you for this one. So we want to do a structure of empty cars. So I'm telling it, could you tell me what the structure is of this data frame? And this is the structure, right? So it tells me it's a data frame. So a data frame, as I said, is an object that has rows and columns, and it has 32 different rows, and it has 11 variables. So variables, you can think of them as columns. So they're kind of different descriptions, different dimensions of an object, right? So for the car, we have 32 different cars, 32 different objects, and they're kind of distinguished on 11 variables. And the variables here are these. It's called, they're different basically descriptions of a car, right? So this is, I think, how much fuel it uses, so how many miles per gallon you get. We have the weight somewhere, so this is the weight. This is how many gears it has, stuff like that, right? Horsepower, I think cylinders. I'm not a car expert, but these are different kind of descriptions of a car, right? So it's giving us a structure, and it tells us this is a data frame, how many objects, how many variables. And then it lists all of the different variables. So it tells us there's a variable called mpg. This is a numeric variable. So this means it's a number. And then it gives us a few examples, right? So it shows a few entries, a few of the first cars in the dataset. And it tells us what kind of values this is, right? This is really, really useful because it kind of helps you understand what the variable looks like. So for something like a cylinder, you kind of see it's a number, and you see that these numbers for the first few cars would be like 6, 4, 6, 8, something like that. So this is really, really nice. Now we kind of understand what different variables there are in the empty cars dataset. And let's learn how to work with those, right? So if I type in empty cars, this lists the whole thing. Usually I don't want that, right? So maybe I just want to focus on the weight of a car. So I might want to get like a mean of this column, right? So to tell the system I only want this column, I type in empty cars. So you type in the name of the data set, and then you type in a $, which tells it focus on a particular variable within that data frame, and then you give it the name. So it's already suggesting names that we could use. So I'll just do weight. And I type in enter, and this basically reduces the whole empty cars data frame to just include that one column, which is the weight column. So now it's listing all of the different weights of the car. So to summarize, there's a data frame called empty cars. And if we want to get the structure of this, so if we want to understand how this works, how this looks, we do str as in structure, and then in brackets we put the thing that we want to get the structure of. In this case it's empty cars. Gives us the structure. This helps us understand what kind of variables there are, and now we can actually work with those variables, right? We can do empty cars, $, which tells it select only one variable from that set, and then we can pick which one we want. So we want maybe, let's do cylinders, right? And it's gonna list all of those cylinders. So all of the different cars, it's gonna list the whole data set, but only that one column. cylinders, right? So it has 32 entries, as we said before, and these are the cylinders for the first car, for the second car, for the third car, for the fourth car, and all the way to the 32nd entry. Let's say that this is not visual enough for me, right? I might want to store this so that I can actually work with this later. And to do this, I might want to assign a new variable to empty cars to just save it into my values section here. And to do that, I would just create a new data frame, a new variable. So let's come up with a name. So let's call this just data. And so I'm creating a new variable like we did before, and I'm assigning a value to it, and the value I'm assigning to is empty cars. So what I'm saying right now is create a new data, a new variable for me that I can work with later. And this one is gonna be empty cars. So I'm taking everything that's in here and assigning it to a new variable. And what this does is, as you can see, it creates a new data for me in top right. And this data is the same as what we just discussed. But the nice thing about this is it stores it into my data, so I can actually have a better look at it and I can work with this in my environment. Let's say I like this function, I want to store it. I go back into my test file here. So this is my test file. On the top left, you can see I have now different kind of tabs because a new tab was open for me when I was viewing all the data. I might want to close this now and just work with this one. So what I'm doing is creating a new data variable, and I'm assigning the empty cars data to that data variable. Once I do this, I'll have a new data here. And the nice thing about this is you can actually click the little arrow here, which does the same thing that we did before. It kind of runs a structure on the whole thing and it tells you what the structure is. But you can also click this little thing in the right, which is like a table icon on the right of data. So here there's like a table icon. And if I click this, it's going to make a new tab for me and it's going to show me this data set in a really visual way, right? So this makes it a lot easier for me to understand and to get an overview of what's happening. I might want to close this now, and let's do some correlations. So let's say I want to do a correlation on two of these things. So what kind of correlation could I want to do? Maybe I want to check if the weight of the car, so WT, has some sort of a relationship with miles per gallon. So how fuel efficient this is, right? Maybe if it's really heavy, then it's not a really fuel efficient car. I will not get as many miles per gallon out of the car. And I might want to find it out, right? So to do that, I would run a correlation function. So let's say you don't know what the function is. In that case, I would do 2 question marks because I don't know what the name of the function is, and I want to do a correlation. It's gonna search all of it for me. And what I actually want to run is a correlation test. And let's find that together. It should be called core.test. So it's the one at the bottom. So what you would actually have to do in practice is kind of read through this and understand which one you want to do. But in reality, what you're going to be doing is kind of memorizing these, right? So you will know that a correlation function has some sort of a name and it's called core.test. So you should kind of remember that now. And if you want to do a correlation in the future, you would just know, oh, actually, I want to do a core.test function. So this is core.test and this is a correlation, and it's going to run a correlation. And the way it works, you can see, you type in core.test, and then you give it parameters. You don't have to give it all of these, right? So this is all of the parameters, all of the settings that you could give it for that correlation, but it doesn't need a lot of those settings. All of these are usually optional. So the only 2 settings you have to give it is the X value and the Y value. So you have to give it 2 sets of data that you want to run the correlation on. So as we said, we want to do weight and miles per gallon. So let's do that together. Let's do core.test. If I did not know how to do this, I could have a look at the example at the bottom right, and that would be really helpful. So this one tells me how to run a correlation and how to actually type in the function and how the results would look like for this data that they created for me. So let's go back to the console. So actually to do a correlation, I just do core.test, and then I type in the 2 different sets of data that I want to use. In my case, it's empty cars. I don't want to use the whole data set. I just want to use one variable. In this case, it's gonna be the weight, comma, and then I give it the second variable, empty cars, and let's do the mile per gallon. So this function is really straightforward. What I'm telling it is do a correlation test on the weight in empty cars and on the mile per gallon in empty cars. I click enter and it gives me the results. So this is a really strong correlation. So I'll just talk you through the results and how they work. So the results, it tells you this is a Pearson product moment correlation. So that's the correlation most people would do. It gives you the t-value. So this is the strength of the association. Kind of tells you how the means and their standard deviations, what the relationship is between those. These are the degrees of freedom. So this is something you might want to use if you're writing like a report on the analysis. Then you get the p-value. So this is how, how the null hypothesis would work. So this is how, basically, is there a strong correlation between these two? Can we trust that correlation? And then actually the main thing that you want to look at is the correlation coefficient. So this tells you how strong the correlation would be between these two variables. And this one is minus 0.867. So this is a really strong negative correlation. So this tells you the higher the value is in one of those, the lower it's usually gonna be in the other one. So really high cars that have a high weight would usually have a low fuel efficiency, right? Which makes sense. If something is really heavy, then it's not gonna give me as many miles per gallon as a car that would not be as heavy. So this is quite a strong, really strong negative correlation. So this is how to do a correlation. Let's say I like this one, right? So I can actually take this and I can store it here. In this case, I did not actually use my data variable. So what I could have done is just use data, right? Because I created my data variable and that is same as empty cars. I have it right here. So what I could have done is just done it like this. So in this case, I'm saying run a correlation on my variable called data. And this is the same as empty cars because I just created my data variable here using empty cars. So this would be the same. I can just show you that it's gonna do the same thing. And it's the same thing, right? So it runs a correlation on data, weight, and data miles per gallon and gives me the result. It's quite nice. Let's say I want to save the result. I don't want to have to run the complex analysis. Maybe I don't want to remember the formula. So what I can actually do is save this whole thing, right? This could be another object. So what I can do is call this result1 and assign so this is a new variable. It's called result1 and it's assigning all of this result to it, right? I can run this and you can see now I have a new result1 variable here. It has a lot of stuff, but if I just type in result1, it's gonna return this whole correlation to me, which is quite useful because sometimes when you do a lot of analysis together, you actually want to be saving those into variables so that you don't get confused easily. So this is a correlation. It's pretty straightforward. To run it, you just do core.test and then you give it the two different variables that you want to do the correlation of. Pretty straightforward, and you can save those results into a new variable that you create. I'll just close these here so we have a better overview of what we're working with. And now let's do a t-test. So a correlation tells us how two variables are related, right? So we have two variables and we want to know, is there a linear relationship between those two variables? T-test is quite different. It's when we have two different groups of kind of participants or two different groups of data, and we want to see if there is a meaningful difference between those two groups. So to do that, let's have a look at our data to see if we can find a data. So data, close brackets, tells me all the data that I have access to by default. And for this one, there was a data with chickens. Let me find that data. I think it's like chick weight. This one, chick weight. So they did, they took chickens and they gave them different diets and they measured their weight, right? So this is telling us how much different chicken weight, and we want to see if the kind of diet, so giving different diet to different chickens, would influence their weight later on, or if they have different weight. So let's have a look at this data set. This is called chick weight. So you can see actually it cannot print the whole data because it's too long, right? So in this case, it doesn't make sense to scroll all the way up or all the way down. And this is where the structure function is really useful. So I can run a structure on chick weight, and this is gonna tell me what kind of variables there are. So I can have a look at the variables, and I can see there's actually 4 different variables. It's telling me what the chicken is, what time. I don't know what the time is, probably the time of the test. But the important one is the diet. So it's telling me there's a factor. So a factor is a group of results, a different group of data. And it's telling me the factor has 4 different levels. So there's 4 different diets the chicken could have. 1, 2, 3, or 4. This is called the diet. And then we have weights. So we measured the weights of those chickens. So let's go back. Let's close this one and let's go back to my data. And let's work with this, right? So a t-test, as we know, is a difference between 2 groups. But in this case, I have 4 different groups, right? I have diet 1, 2, 3, and 4. So if I did something like chick weight, and then I just want to see the diet data, it would list all the data. So these are all of my chickens in the data set, right? And I can see how many of them are diet number 1, diet number 2, diet. So this is kind of how the diet variable of that data set looks like. But you can see there's 4 different groups of diets, right? 4 different levels of the variable. So for my analysis, I just want to remove some of these because I want to do a t-test, and a t-test can only handle 2 different groups. So to do, let's say we want to do only group 1 and group 2. In this case, I would want to reduce the data set, right? So I would want to take the chick weight data set, and I would want to actually exclude some of those, or in my case, only include those that are either 1 or 2. So I'll teach you how to do that right now. So what we actually want to do is a subset of the chick weight data set. So to create a subset of something, there's a subset function called for the there's a subset function in place for that. So what a subset function does is it takes a data set and it reduces it based on some property that I give it, right? So for example, it's called subset. You can do a question mark to get a better idea of what the function does. So this subset vectors, matrices, and data frames. So it returns a subset if it meets some conditions. You can have a look at the examples. So you have examples at the bottom. It's quite nice examples. It tells you can take air quality and subset it where the temperature is above some variable, right? Some number. So in this case, it's going to return entries where temperature is above 80. In my case, I want to return entries where the diet is either 1 or 2. So this is quite complicated, a bit complex. So let's try it together. So I want to do a subset of chick weight. So this is really straightforward. I'm just saying do a subset of chick weight, then I do a comma, and then I tell it what the rule should be, right? So in my case, the rule is quite complex. I want to take the diet, and I want the diet to either include 1 or 2. So to tell it either include 1 or 2, I would have to create a set that has 1 or 2 in it, right? So we did this already. So actually, before we do this, let's talk about sets a bit more. So to create a set, we need to combine things together. So I'm telling combine 1 and 2. So this creates a set for me that's 1 and 2, which is quite nice, right? Because that's what I need for this task. So I'm creating a subset of chick weight, and I'm telling it the diet should be in my set. Hopefully this works. I think it works. So let me just bring if I click an up arrow, it's gonna bring my last thing that I typed. So this is quite nice. We can go all the way up, clicking up arrow just to show you the diet, and then I'll show this one. So this is quite nice. So what I'm doing is I'm creating a subset of chick weight, and what I want is the diet number. So all of these numbers, I want it to be in this set. So this set is 1 or 2. So if there is diet in 1 or 2, it's gonna include it in my subset. If it's not true, it's not gonna include it in my subset. So the way subset works is it goes through all of these entries, right? So it's gonna go through the first line and it checks in chick weight for the first entry is diet. So is number 1 in 1 or 2? Yes. So it's gonna include this one, right? Goes is number 1 in 1 and 2? Yes. So for all of these, it's gonna include them. Then it goes number 2. Is number 2 in 1 and 2? Yes. So it's gonna include all of these chickens. And once it gets to number 3, it asks, is number 3 in 1 and 2? no, that's not true. So it's not going to include all of these in my subset. So it's going to remove all of these from my data. If I just do it like this, it's going to print it out, which is nice, but not really useful to me, right? So I want to actually take this and store it in a variable that I could use later on. So let's come up with a variable name. So chicken data or chicken analysis. I think that's nicer. So what I'm saying right now is create a new variable called chicken analysis, and I'll assign something to that variable, right? And the something is gonna be a subset of chicken weight where diet is in 1 or 2. Done. So this is done, right? I can have a look at my chicken analysis here. So it's now in my data. It has 4 variables, and it should not have any chickens with 3 or 4 diet. So let's check that. Chicken analysis diet. And these are my values. So you can see there's 1s and 2s. But you can also see that actually it did not remove those groups. So it just removed those entries, but it did not remove those group labels, and that's gonna really mess up my analysis. So I want to clean this up a lot. I want to remove the levels, so the kind of groups that are not in the data set anymore, right? So it just removed the chickens, but it did not remove those groups. So what's happening at the moment is that my diet variable, it still has 4 levels, so it still has 4 groups, but it has no entries in those 2 groups. So what I actually want to do is clean this up and tell the system, actually, if there's no chicken in that group, just remove the group, don't keep the group. And to do that, there's a function called drop levels. We can ask what it does. So it uses unused levels from a factor, right? So it goes through the factor and it asks, actually, is there chickens in all of these groups? If yes, keep that. But if there's a group that doesn't have any entries, it's gonna remove that group. It's gonna exclude it just from, it's gonna remove the group. So I can actually do drop levels. And then I could either give it chicken analysis diet, or I could just give it the whole chicken analysis. And what this is gonna do, it's gonna clean up all my factors, right? To remove the levels that are not used. If I just do it like this, it's gonna print the results, which is not what I want. What I want actually to happen, let's think about it together. So what I want is I want chicken analysis, my data set, to actually be the fixed data set, right? So what I'm doing is something like this. So what I'm telling the system is chicken analysis, what you should do is assign a new value to it that's gonna be the chicken analysis with the dropped levels. I just realized I was not typing it up into my sheet. So let's fix that together. So let's do it like this. You always want to, whenever you do some code that you actually think is useful, that you're gonna be working with later, you wanna save it into your sheet at the top so you don't lose the code. So what you see we did is we created a chicken analysis variable that was a subset of chick weight, where diet was in the set of 1 or 2. And then we created a new variable, which is the same thing, same name. And what that is actually just dropping the levels on chicken analysis, right? So it creates this one, and then it drops the levels from it to fix it for us. So I have to run this one as well. And now I can actually check, so I can do structure, chicken analysis. And this gives me the structure, right? So I can see the weight, the time, the chick, and the diet. And the diet is now actually only including 2 groups, group 1 and group 2. So we have 2 different diets of chickens. So let's think about a t-test now. So I want to check if the diet in group 1 and group 2, if those are meaningfully different when it comes to the weight of the chicken, right? So I maybe want to see, is administering diet 1 and diet 2 to those groups, is it gonna lead to different weights of those chickens? So to do that, a t-test is really good because that's comparing 2 different groups. The way I can do a t-test, there's 2 different ways. All of them include the t-test function, right? So I can ask how this function works. So this is a student's t-test, and it performs 1 and 2 sample t-test on vectors of data. You see all of the all of the arguments here. So this is all of the things you could set up. What you really have to only set up is the X and Y if you don't want to change any of these, right? Could be that sometimes you want to change these and that's fine. You could add them, or you just don't want to mess with these at all. In this case, you don't have to include these arguments in your formula at all. If you're confused, you can always have a look at the examples. These are really, really useful. So it tells you how to set up the data and how to create some of these. So let's do a t-test together. So I do t-test. And one way to do it is give it a column of values and another column of values. The first column would be the first group of values in the first group condition, and the other one would be the second group of values in the second group of condition. It depends on how your data looks, right? So in our case, the way the data looks, sorry, I'll just scroll up a bit. So this is our data, right? We have weight in one condition, and then this is a condition assignment. So it tells us, is this chicken in group 1 or group 2? In this case, we want to actually tell it that this is not a set of values that we want to do the t-test on, but this is the group category, right? So my values are always in this one, always in weight, that's my weight, and the diet is the group assignment. So this tells me, is it group 1 or group 2? In that case, I use the wave symbol in this formula. So I tell it which is my data column. So I tell it, do a t-test on chicken analysis and weight. So I want to check the weight difference. And then I use a wave symbol to give it the group variable, right? So the group variable is going to be chicken analysis and diet. So what I'm telling it is, do a t-test on chicken analysis weight grouped by chicken analysis diet. And it gives me the result, and it tells me there's 2 groups. And the mean in group 1 is 102. The mean in group 2 is 122. And the t-value is minus 2.63. These are my degrees of freedom, and this is the p-value. So the p-value tells you if this was the same group, if there was a no difference at all, right? If this was coming from the same population, how weird would those results be? How extreme would those results be? If it's a really, really low value, it means those results would be really, really weird, really extreme if they came from the same population. So in this case, this means if those 2 groups of chickens were the same, if there was no difference, that would actually be a really, really extreme result, a really, really extreme sample. In this case, I can therefore conclude that groups 1 and 2 are quite meaningfully different on that variable. So if you just want an easy way to think about this, is if the p-value is really, really low, then the groups are different. If it's really, really high, then the groups are likely to be the same. So in this case, the groups are different. I want to save this, right? I want to save the result. So I take this and I assign it to a variable called result2. I run this. And now I have a result2 here, right? So I can type in result2. And it's gonna give me the data from result2. So to summarize, what I did is I created a subset of chicken weight, reducing the factor of diet from 4 different levels, from 4 different groups to just 2 groups, because a t-test cannot handle more than 2. Then I dropped those unused levels, and then I saved the results of the t-test into my result2 variable. And you can see how this is becoming really, really useful, right? Because now I'm storing all of the things that I did, all of the things that worked, and I'm saving them here. So I can see exactly what I did, and if it did not work for me, I can go see my friend, and my friend can show me his code, and his code might be slightly different, so I can ask, oh, what did you do differently? How come it works for you and it doesn't work for me? And because we use the same programming language, it's always R, we use the same data, we can always see how my kind of manipulations with the data are causing effects in the results, right? So if it's not working for me, it's gonna be really, really easy to find out what I did differently to my friend who, you know, has a working piece of code. So in this case, I think R is really, really powerful, and it's why people use it. You can imagine if your analysis was super complicated, it involved like 30 different steps. Keeping a track of all of these steps and being able to run all of these would be really, really useful. Very last thing I want to show you, because we did all of this, we can actually just run it using the code now, right? So let's clean up my data. So this is all my variables on the right that I just created as I was working with you in this video. If I want to clean them up, if I want to remove all of these, I can click the broom icon. And this will remove everything that I created from my environment. I'm quite happy with that, so I click yes. And now I have no more variables, right? If I type in chicken analysis, it's not gonna know what it is, because I removed it, right? So the object chicken analysis is not found. But the super nice thing about this is that I have the code, right? So the code is kind of my instruction to repeat what I just did. So I can do just that, right? I can select the code to run, and I can run the code. And it's gonna rerun the whole code. And now it's gonna give me the results super quickly because the code is written. So this is really nice. I can just, it did basically all of the analysis that took me like 40 minutes because I have the code, it knows how to do it. So I can just type in result 2. And it's gonna return the result for all of the analysis that we did together, which is super powerful. So right now what you should know by the end of today is how to work with some of the data sets. You should know how to find functions. So if you want to find function, remember you do 2 question marks and type in what you want to find. The t-test, right? It would find different functions with t-test. If you know the name of the function and you just want a description, you can do just 1 question mark, mean. It's gonna tell you how the mean function works. We learned how to store data. So if you want to create a new variable, you type in any name for that variable and you assign it some sort of a value. We learned how to create lists of data. So that would be combining different things together, like 2, 4, and 6. And this would create a new variable called new variable with assignment of 2, 4, and 6. And then we did all of these things together. I showed you how to find the data sets that are included, so you can kind of mess about with the data that's in there. That's doing data with brackets, empty brackets. It's gonna open a window with all of the data sets that we have. And then we did 2 tests together. We did a correlation, so that's core.test. If you wanna know more about it, just use the question mark, core.test. This will give you more information, and most importantly, it always gives you examples at the end. So I myself still use those examples to know how to do this properly. This is really useful when you have some really complicated functions that require a lot of steps to set them up right. Then we did a subset, so you know how to create a subset. A subset takes something and it reduces it based on a rule. So it only includes entries that kind of match this rule. And then we learned how to clean up our factors. So if there's a group that doesn't actually include any entries anymore, after our subset, we can drop those levels. And we learned how to do a t-test with a grouping variables. So that we, in this case, we use the wave symbol, and the wave symbol tells it this thing following the wave symbol is actually not a set of data, it's a grouping variable that tells us what group the data is from. In this case, is the chicken eating diet 1 or diet 2? And we did a t-test and we went over some of those results. So I think this is a really good foundation to working with R. By the end of today, you know how to do correlations or t-tests. Keep in mind there's like hundreds of thousands possible functions that R has, right? So that's really powerful about R. Whereas Excel or Google Sheets, they would have only access to a handful of functions that make sense for a spreadsheet. A thing like RStudio or R, it has access to a lot more things that make sense even in this context. I'll do one more video for you later, which is going to be about importing your own data. It's going to cover what we did today. So if you know what we did today, if you can actually do t-tests, subsets, and correlations, then you know a lot of stuff, right? That's a really good start. And we're going to do plots and some subsets in the later video. So thanks a lot for listening. If you have any questions, feel free to leave them under the video in the comment section, or you can send me an email if you want to. So thanks a lot, and I'll see you next time.